In the previous lecture, we have discussed about the division method in hashing. It's one of the technique used in hashing. But using the division method, it may lead us to the collisions. Let us see what is collision. Suppose let us try to insert the elements 1, 11, 2, 3, 4 into a table of size 5. Let us apply the function f of n is equal to k mod table size. So 1 mod 5 is 1 and 11 mod 5 is also 1 and 2 mod 5 is 2, 3 mod 5 is 3 and 4 mod 5 is 4. Here if we see that these both elements are pointing to the same index. As we know that in one index we can store only one element, but this hash function is generating a same index value for both the elements. This condition is called as a collision, and we have to overcome this collision because all the elements need to be adjusted in the table and there should be no collision conditions. So to solve this, we have some collision resolution techniques. Let us discuss about the collision resolution techniques. So these are the collision resolution techniques. It is broadly classified as two types: open hashing and closed hashing. Under open hashing, we have a concept of separate chaining, and under closed hashing, we have concepts of linear probing, quadratic probing, and double hashing. Now we are going to discuss about separate chaining. So this is the technique of separate chaining. Generally, separate chaining is implemented using the linked lists. To insert an item in the hash table, we should create a linked list and place the item in it and then store the pointer to the linked list in the corresponding hash table. So in this separate chaining, we will first store the item which is to be inserted in the hash table in a linked list, and every linked list will be having a pointer, and that pointer will be stored in the hash table. And if collision occurs, the new item will be inserted in the corresponding linked list. So if the collision occurs, we will insert a new node in the linked list which was already created earlier. So in this way the separate chaining technique is implemented. Now let us see it with an example. So let us consider this example: insertion of these elements into the hash table 1, 11, 21, 4 and 3, and as usual our table size is 5. So first, as stated in the definitions, we have to suppose inserting the element 1, we have to store that in a linked list, and we have to perform. Now this is the linked list and we have to store the pointer of this linked list in the hash table. To determine the position of the pointer, we have to apply the hash function on this element. So 1 mod 5, it is 1. So in the first index we are storing the pointer. In this way we will store the first element. The linked list pointer will be stored in the hash table and the element will be stored in the linked list. As the name suggests, it is open hashing, so the hashing is done outside of the table. So only the pointers will be stored inside the hash table and the data will be stored outside of the hash table. Now let us insert 11. Now again 11 mod 5, it also generates the same index value 1. So here we are getting the collision. So we have to add this 11 to this linked list because we have encountered the collision. So we will be storing the 11 in this index. So in this way we have overcome the problem of collision by storing in the linked list. In similar way, the next element is 21. Again 21 mod 5 generates as 1. So again we will be storing the element in this same linked list. So these three elements will be stored at this position 1. Now while retrieving this element, we will apply this hash function on this one, then it retrieves the index 1, and in this linked list we will be comparing with this element. So in this way we can retrieve the element. Next, our inserted element is 4. So as you know, 4 mod 5 is 4. It will be inside, the pointer will be stored in the 4th location and the element will be stored in the linked list. Similarly 3 mod 5 value is 3. So we will be storing the pointer of that linked list in this 3rd location and the element in the linked list. In this way we can store all the elements using separate chaining method. As we know, all these elements are stored in the chain, so we are calling it as separate chaining, and all the hashing is done outside of the table, so it is called as the open hashing. Now let us discuss a case, a worst case in this. Let us suppose that the elements are 1, 11, 21, 31 and 41. As we know that if we apply mod function on all these elements, they all will generate 1 as the index number. So we should store all these elements in the linked list. If we want to retrieve the element 41, we have to search all these elements. So in this, the worst case time complexity is order of n, because we have to traverse all these elements to reach 41. But hashing ensures that the searching and retrieving is done in order of 1. But using this technique, we have a drawback that in the worst case, if all are kept in the same chain, then the order of time complexity of retrieving the last element is order of n. This is the drawback of this separate chaining technique. This can be overcome in the further discussed techniques in the next tutorials. Thank you.